Hello everyone. Today's tutorial is about updating the display on the 746 display. I had somebody ask about a tutorial with update from Uart, so I have to assume that he meant updating the display with Uart information. So we're going to use an existing project, and I'll have a link below that on previous video that I created a project using the latest TouchGFX 4.13.1 and I'm sorry, 4.13.0, and then the Cube IDD 1.2.1. So alright, so here we'll go ahead and open up TouchGFX, and we'll start that project here. And I'm going to go ahead and change this background color to something darker, and go ahead and add text box here, and I'm going to uncheck this so I can make this wider, and then change the text color. And here I'm going to change the text to RX with a space. So that's just your received message. And then here I'm just going to add a wildcard, and then click this button here, and I'm going to check this box, and I'm going to increase the buffer size to 17. In this project, I'm going to be using a buffer size of 16 for the Uart message, but TouchGFX requires for this buffer to be one more size than what it's receiving, so that the last index will be a null character, and that's what's required. So whatever message buffer you define in your project, make sure that this buffer's one size larger. Alright, and then because we're using wildcards, we have to go under here, text, and then set typographies tab. We need to go to default. The default is what's used for that wildcard, and we need to define a wildcard ranges. So when you receive a Uart message, it knows what characters are that this needs to generate and to be able to use in the display. So we're going to start with the ASCII character space, so it'll be 0x20, and we're going to go up to, I believe it's the tilde character, so that would be 0x7E. And then we'll just increase this text size a little bit. We'll go 27, so this got a little bit bigger. And go ahead and generate the code. Alright, so you can see here we have the RX, and then we have value. So whatever we receive and want to display, the value right here will get replaced. RX colon will always stay here. Alright, so open up the main.c, And what I'm going to do is I'm going to create another file called polling routines. The reason being is that from previous projects I've done, I've been writing code and different tasks, and this project only has one task. So I'm writing some code and generating from CubeMX some new stuff and new pinout, adding some peripherals, changing some perimeters. There was a time where CubeMX locked up and the code was or the file was corrupted where I couldn't even open it up. None of this was showing, so I couldn't even do a save as. So whatever code I had written was lost. So now I trained myself to just do a whole new different file. So I'll call this polling routines. And then I'll include the header file for that. Alright. Then back to main, I'm going to include that header file here. I'm going to add a couple functions here. Oops. Calling a knit. And go ahead and add these prototypes here. And then I need to add, tell the compiler that this is a C file because this is a C++ project. If you don't tell the compiler that this is a C file, it will generate some errors when compiling. Alright. Define here, so this defines a UART buffer size of 16. So remember when I was talking about in the TouchGFX that I had a buffer of 16. This it could be whatever size that you want. I believe TouchGFX says the maximum characters is about 60, I think, or somewhere around that range. So you'll have to read up on that, but I'm just sending messages under 16 bytes, and that includes the line feed and character returns. And then in the TouchGFX, that array was one more byte than the buffer that size that it's going to receive. All right, so close that. So go ahead and add alright, so I need to receive the UART messages, but I need to actually open up this IOC file, and I have to enable the UART because right now it's turned off. So on the Arduino connector, there's UART 6. So click UART 6 here, and we're going to enable it. asynchronous, and we have to make sure we have the global interrupt enabled, and everything else is at default, and we're using a baud rate of 115/200 here. Then we need to go ahead, close this, go to middleware, free RTOS, and we need to add a task. And we'll call this task Uart message. And that was the name of it, and then this one will be the function. Uart message. Okay, and then we need to add a binary semaphore. So under here, timers and semaphores, binary semaphores, add, and we'll call this binary sem Uart message. Okay. And again, so when you enable Uart, make sure this global interrupt is enabled. Several times I forget to enable that. I'm wondering why is my Uart not interrupting or updating the display. It's because it's not interrupting to receiving message on the Uart. Alright, so we go ahead and save this, generate the code, yes. And the file wasn't saved, so it's asking if we want to save it, so yes. Alright, so we don't need this anymore, close that. So I need to paste the Uart receive callback here. So best thing to do is here is go under drivers, the HAL drivers, source, and the Uart.c, and the function we're looking for is going to be the RX complete callback. So just like that, we'll just Control K until I get to that. There it is. So we go ahead and copy this function without the weak and place that in the polling routines. Alright, and then go ahead and add some more code here. So I'm including a string here because we're going to do a mem set, and then the CMSys which is the free RTOS for this binary semaphore. Without this, compiler is not going to know what this the structure of this is, and this binary semaphore is already defined in main.c, so that's why we're doing an extern. And then let me see. Oh, then this Uart6 it was defined already, so we're telling the compiler that it, extern, and copy some code. And the reason why we need that Uart6 is in this polling init, and let me see, make sure that here before I jump to here, we need to to add this polling routine or polling init to our new task that we created, the Uart message. We only need to call it once, so we'll paste it here before the for loop, and then we need to call the polling routine inside this loop. So polling init gets called once, and then polling routine continuously gets called. Go ahead and save that. So again, polling init gets called once, polling routine gets called continuously. So polling init, we need to enable the Uart receive interrupt. If you don't call this, when you get a message on the Uart, you're not going to get this callback because the interrupt is not enabled. Okay, so copy some more code here. Alright, so we had our message buffer here, and the size is 16. Then we have another variable here that we're going to save 1 byte, because we enabled the Uart and we're looking for 1 byte, and we're saving it into this array. So when we get a 1 byte, we're going to get an interrupt. And then here, I'm going to skip this section for a second, but here, that 1 byte, we're checking to see if it's a carriage return, which is 13, or I don't remember, what was it, 0x0d is the carriage return in hexadecimal, but this is decimal. If it's not a carriage return, then it is some character, so we're taking that 1 byte, saving it into the buffer, and then we're incrementing the index pointer, and then we're jumping out, and then we're re-enabling the Uart receive interrupt. And again, we're looking for 1 byte, and we're going to save it into this array. So as we're going through and receiving these bytes, when we get to a carriage return, and not a carriage return, then we jump down to here, and I'm just going ahead and save that carriage return into this last index of the array, and then I'm taking this index and clearing it, and then this message ready flag, I'm setting it to indicate there is a message ready. And this tutorial is about sending the data from the Uart to the GUI. So there is no error checking here. So you have an invalid character. It's going to get passed through. So you have to do your error checking to make sure you're within the range, the correct character range. If you're doing something that's less than the 0x20, which is the space, those going to be invalid characters that the TouchGFX is not going to recognize, up to 0x7e. So this is just a basic way of receiving the Uart message, but there's no error checking. So if you want to do that, you have to write your own code to do that. Alright, so back to this message ready flag. Go ahead and copy some more code here. Alright, so we get a message. So this polling routine gets continuously called So always check. We're here checking to see if there's a message ready. If there is, then we're going to go ahead and give this binary semaphore that we created. So it's giving it. So if you remember, or maybe I didn't talk about it yet, but I made a previous video on how to use the view model that TouchGFX creates and communicate between this main program, whether it could be main.c, and here I'm using main polling routines to communicate to the model, and then from the model communicates to the presenter, and from the presenter it goes to the view, and then the view is what updates in the GUI. So from here we need to talk to the model. So let me go back, just close that down, open up GUI here, source, model. Alright, so here in model we have the tick, so the FreeRTOS is always calling this. So it's just like my polling routine, it's always calling that polling routine, and so tick is always being called. Copy some code real quick. Alright, so we're including the header for the FreeRTOS. This binary semaphore was already created in the main.c, so we're telling the compiler that it's an external variable. Alright, so here we're just checking to make sure that it's has been created. If not, we're not going to enter it here. Here it's going to try to take this binary semaphore that was given from the polling routine. So if it's true, we're going to call this Uart message ready function, and we're going to create that here. And then we need to include that in the header file as a prototype. Save. Alright, so again, we're calling this function, which is here, and then from the model we need to call the model listener. So here, if we go to include GUI model, there's a model listener. So we open that up, and then here copy and paste. We're including the Uart message ready here, and this has curly brackets instead of semicolon. So go ahead and close that. And then here, let me save all that. Here, now we can call the model listener. message ready. Go ahead and save that. And then we need to go to this screen or the presenter, which is screen 1 presenter, and we're going to be calling from the model to, or the model present or model listener to the screen presenter. So create that. So presenter, and this is Uart message ready. So we're creating this function, and again we need to include this in the header file as a prototype. Okay, close that, save. Alright, from screen screen 1, the presenter, we're going to call the view. So here, go ahead and create another function. And this is view, not the presenter. And this will be your message ready. And it's the same thing, we need to add the prototype to the header. Alright, so now we're in the view. We just received the from the polling routine that there's a message ready. You know, we have the binary semaphore going to the model. So it's the model, and then we're calling this function, and then calling this function in the model listener, and then model listener will then call this Uart message ready in the screen presenter, and then here we need to call the view. So we'll just put a view Uart message ready. There we go, and that's it. So screen 1 presenter, that's it. That should be it for the model. So from here, we're going to update the GUI. Alright, so including string, because we're going to do a mem set, and then polling routine. So it defines that polling routines has this buffer here. So here is the buffer from the polling routines that we saved the message from the Uart. Just checking to make sure that there's a valid message. If the first index is 0, then there's no message at all, so we just return. If there is a message, then I'm doing a mem set on this text area 1 buffer, which was the buffer for the TouchGFX text that wildcard that we created. And this text area 1 is 17. So remember, this array has to be 1 byte bigger than what it's receiving. Then here the string copy is taking the Uart buffer message that we received, and then we're copying it over to the, this buffer here, and then we're taking the last index and placing a null character. And this text area 1 is the actual text on the layout, and has the RX colon and then the wildcard. We need to do an invalidate, and that'll refresh that text box, and so whatever message we receive, it'll refresh and then show that text. I believe that's it. Let me go ahead and compile, see if there's any errors. Alright, so looks like compiled correctly. No errors. So we'll go ahead and run the debugger. Alright, so it's ready to go. Go ahead and run it. You can see it here that we got our layout. Toggle button works. Toggles back and forth. We got our RX here. Let's start up the dock light here, and then go ahead and I'm going to send the hello world with a line feed and carriage return. And you got to remember that line feed and carriage return is an 2 bytes, so you got to make sure that whatever you're sending in total is 16 or less bytes. Otherwise you're going to get an error index out of range or whatever, and it will go into hard fault, and your program will lock up. So there you go. It's just sent hello world. You can see that it updated the text. So I'll go ahead and send the next one here, the STM32, and then here you go. You can see that it updated, and ABCDF. So updated, and then 0 through 9. So there you go. And back to hello world. Alright, so there you go. So that's how you take a Uart message and save it to a global variable that the view can access, and that the main or polling routine had defined that global variable, and it can save that message there. And how to notify the model that there's a message ready, and then the model has that tick, so it checks to see if there's a message ready using that binary semaphore, and then it calls that function Uart message ready, and then from there it goes to the model listener, and then the model listener calls the presenter, and then from the presenter it calls the view, and now that the view gets called, it knows there's a message ready, so it copies that over to the variable that's the text on the LCD, and then it invalidates it, and so it refreshes this the text. So if you like this video, give me a big thumbs up. I will next video we'll show you how to take the soft buttons like this toggle button and go ahead and message or notify the main, which will be the main.c, or the polling routine, that there's a button notification. And what I'll do is turn it on and off this LED, that's the green LED here. So that will be the next tutorial. So thank you.